Hi, welcome to today code walkthrough. So today we are going to see a very basic concepts in C, that is the number systems in C, how we are going to represent the numbers. So basically there are four types of number system, which is the decimal number system, binary number system, octal number system and hexadecimal number system. Let us walk into the decimal number system. So decimal number system, we usually use the digits 0 to 9. So as you can see, there are only 10 digits. So since we are going to use only 10 digits, we call it as the decimal number system and its base is 10. So what is the place value of any digit? For example, I have taken example 456. So the value of 5 is basically 50. So its face value is 5 and into 10 into position minus 1. So its value will be 50. So as we can see, for 456, 6 it is in 0 position, first position. So 1 minus 1 is 0, 10 power 0, which will be 1. And then we have 5. 5 is in the second position. So 2 minus 1 is 1. So 10 power 1 will be 10. And 4 into 10 power 2, that is its position is 3, so 3 minus 1 will be 2. So 400 plus 50 plus 6, so this number is represented as 456. But let us think, this 456 is a number which we actually see. Will computer recognize this number? No. So computer will always recognize the number in terms of 0 and 1. So binary number system, I will call it as the computer numbers. As a computer only understands a 1 or 0. For example, in the case of 456, if you're going to represent the entire number in terms of zeros and ones, will we as a humans would be able to recognize it? No, we would not able to recognize it. So computer basically uses the binary number systems, so which we can see how they are going to represent the decimal number. So as you can see, a combination of 1 and 0, they form the binary number system. As only 2 digits are used to represent any number, only 2 digits, so binary or base to number system it is called as. For example, we have taken a number which is represented in a binary system. It has only zeros and ones. In decimal, how we are going to represent? So for example, I'm going to take this number. So when we are going to write in the binary notation, I would like to say one more important concept. The concept being that the one which is present here, we call it as the most significant bit, and the one that is present to our right hand side, the last, which we call it as the least significant bit. So this one, it is called the most significant bit, and this one is called this bit that is present in my right hand side, it is called the least significant bit. So as we can see, we take this one. So 1, it is in the position of first position, so which is the zeroth position. So we call it as 1 into 2 power 0. Then this 0 into 2 power 1, 1 into 2 power 2. So similar in the case of decimal number system, where we use an increasing power of 10 power. Here, since it is of binary, we are going to use 2 power. So 2 power of position minus 1. So this is how we are going to represent the number. So correspondingly, we have 1 into 1, 0 into 2, 1 into 4, 1 into 8, 1 into 16, 1 into 32. So when we add up, we get the decimal digit of 61. So there is one more number system called Octal Number system. So this system uses digits 0 to 7, that is 8 digits. It's used to represent a number. Since it uses only 8 digits, we call it as the base 8 number system or octal number system. For example, 24, how we are going to represent? So since we use only 8 numbers, we call it as 4 into 8 power 0, that is position minus 1, and 2 into 8, 2 into 8 the power of 1, that is 2 minus 1, so 1. So we got the decimal number 20 in the decimal. So there is one more number system called hexadecimal number system. So basically, computers, apart from binary, another widely used number system which computer uses is hexadecimal number system. They actually store it in terms of zeros and ones only, but in groups of hexadecimal number system. So in this system, the 16 digits is used to represent the given number. So since we use the 16 digits called base 16 or hexadecimal number system. So each digit position represents a power of 16. So similar to the binary or decimal where we have seen 10 power, 2 power, 8 power, here we use 16 power. So as the base is greater than 10, so we have to represent numbers apart from 0 to 10. We have numbers pending like 10, 1, 0, 11, 12, 13, 14, 15. So these numbers how we are going to represent. So after 9, the 10 we call it as A, and 11 we call it as B, 12 as C, 13 as D, 14 as E, and 15 as F. So this is all the basic concepts of the number system. We'll dive deep into how we are going to convert from one system to another system, and how as a programmer we are going to manipulate these numbers. I'm going to explain in detail in this video. So let's get started. So as I already said, there are different types of number system like decimal format, binary, hexadecimal, and octal. So each 8 bits, we call it as a byte. So what is this each bit represents? In the case of binary or number system, we usually represent numbers in terms of zeros or ones. That 0 or 1 is going to occupy the 1 bit position. If 8 such bits is grouped together, we call it as a byte. Of this, or among those bytes, half that byte can be split into half. We call it as a half byte. We also use the term nibble in order to represent a group of only 4 bits. So that's 1 byte has got 2 nibbles. So for example, decimal number system will be of the format like 9, 22, like that. So binary number systems can be represented only in terms of zeros and ones, and hexadecimal number system can be represented like 0 to 9 and 8 to F, which we already saw, and octal number system with 0 to 7. So I already explained that the left hand side is called the most significant bit, and this right hand side bit that is present is called the least significant bit. So for example, I'm going to convert the decimal 30 into binary. How I'm going to do? So we have seen how to convert, how to represent a decimal number from binary to decimal. That conversion we have seen. Now actually from decimal to binary, how we are going to convert? So in the reverse way, binary to decimal we have seen. Now decimal to binary. So number 13. So first the 13 we have to divide it by 2. And what is the quotient? That is 6 2s are 12. So that 6 will be represented in terms of quotient, and 1 will be the remainder. So which is bits portion 0. And then the 6 will be divided again by 2. So we have got 3 and the remainder as 0. And this 3 we again divided by 2, and we get the quotient as 1 and the remainder as 1. And again this remaining 1 we try to divide by 2, but what we'll get, we'll divide, this is 0 and our remainder will be 1. So thus we get the number 1 1 0 1. So now we try to convert this again back to the format where we use decimal format. So 2 power 0, that is 1, plus this will be 0, and this will be 1 into 4 and 8 into 1 into 8. So thus we get 8 plus 4 plus 1, which is nothing but 13. So thus we got the decimal number 13. So this is how we are going to convert the decimal number to binary format. So similarly, if you are going to convert decimal 9 to hexadecimal, So usually we use to convert the decimal into a binary format and then back to the hexadecimal or octal will be much more easier. So we programmers we usually tend to approach in that way. So for example, I've taken digit 30. So 30, the similar method which I explained before, we have converted this number 30 into a binary format. Thus, its number will be 11110. So this is the format which we have got. So 11110. So this how we are going to group. As I already said, up after 9 hexadecimal we used to represent the number as 10 as A, 11 as B, which I already told. Now hexa number. So now I got the number is I have got how many bits I've got? I have got five bits. So 1, 2, 3, 4 and 5. So now I'm going to split into 4 bits. So I have written the last 4 bits as 0, 1, 1, 1. I have 1 remaining. I have prepended 3 more zeros ahead of 1. So now what value I've got? So this 1110, I know this position it is 1, and this position its value is 2, and this position its value third bit position from my right hand side it is 4 and then 8. So 8 plus 4 plus 2, which is 8 plus 4 is 12 and then 13. So 13, how we are going to represent? Is it 13? No, 8 plus 4 plus 2, which is 14. So this 14, how we are going to represent? It is E. We are going to represent it as E. And then I have only 1. So what is the portion? 2 power 0. So that is 1. So the 1 into 1 is 1. So 1, that is value. So this number, which is we usually, this number 30, we represent the form of 1e. So first we'll convert into a binary, and from binary we usually use it to group in terms of nibble 4 bits, and then for 4 bits whatever the value we write it correspondingly down. So 1e. This is how it's much more easier to convert. Then we go for the octal. So how we are going to represent the same? So for example, I have got 4 ones then 0. In case of hexadecimal, I have grouped it in terms of nibble. In terms of octal number, I am going to group it in terms of 3 bits. So why I am going to group only 3 bits? The maximum value of my 3 bits is 1 plus 2 plus 4, that is 7. Maximum my value is going to be from 0 to 7. So I am going to group in terms of 3 bits. I am going to write it down. For here my 0, its value is 0 into 1 plus second bit, that is 1 into 2, and another bit 1 into 4. 4 plus 2 will be 6. I am going to write down 6. And then again moving to the next 3 bits. So the 1 into 1 is 1, and again I am going to have one more 1, so that is 1 into 2. So 2 plus 1 will be 3. So the value of 30 in octal representation is 36. So this is how basically we will have the conversion. So from 0, for example, I have 7. Then in binary format, all my 1, 2, 4, everything will be set as 1. So it will be represented as 1. So only when it goes from, when you go to 10, as we know, this three bits we are going to split off. So the first 3 bits from my right hand side, from the least significant bit, it will be 0, and one more bit I am going to add here. I am going to prepend it with 2 more zeros, so 1 0 that value will become. So this is how we will be converting the number from one number system to another number system. A quick recap is we always use only the computers always recognize any numbers as the only in form of zeros and ones. So next we'll go ahead further. So how we are going to convert decimal to hexadecimal. So which we already explained, from decimal to hexadecimal means easier way will be we have to first convert decimal number to binary number, and 4 bits we are going to group, and for that 4 bits, what is the hexadecimal value, we are going to write it down and we'll get the hexadecimal number. So this we already explained, a quick program which will help us to convert from one number system to another number system. I have certain few more topics like bit manipulation, left shift operator, right shift operation, and or. So once I have explained all those basic concepts, I will dive in deep go through the some of the bit manipulation programs. So let me quickly run through this program. So as we can see, the decimal format for example 15, it will be D in hexadecimal, and 115 it is in the case of the octal number, and how it is being represented in terms of the binary format. So 101, its value is 5, it's written in the octal, and the remaining 1, it will be written in the uh, next as a header. So this is how we are going to represent the number system. In order for you to have a quick hands-on of what are these number system, I've prepared some of the assignment questions, so which you can go through, and you can just comment this in my chat box, post in the comment, so we'll verify. So how would you represent the number 8f in a binary format? Similarly, f means this one example I'll tell of how to do. So you have 8f. So similarly, if once you by every 4 nibbles you group it and form the hexadecimal number. Now in the reverse we are going to do. So 8 means what is the equivalent binary format? So the number 8 usually represents as 1 0 0 0, and f, all bits will be set to 1. So 1 1 1 1. So this is the numbers binary format for the 8f in hexadecimal. So similarly, we have to represent the number octal 67 in binary format. So 67, how we are going to do? 7 means 3 binary bits you are going to write corresponding to it, and 6 means 3 more binary bits. So like that you'll be converting into the binary format. So now one more question is represent the number 101101 in hexadecimal, decimal and octal format. And this fourth question is we have to represent decimal number 17 in binary, octal and hexadecimal format. So just practice these questions, so you will be having hands-on, and you will have a grip on the what are the number systems that will be used in a C language. Please watch the next upcoming video for a detailed explanation of what are the bit manipulations. Thanks for watching.